So good morning, everyone. It's a pleasure to have all here in this important side event of the UN Water Conference with the theme, the new water science to achieve UN Sustainable Development Goals. We have a group of top scientists today to discuss this issue of the molecular and nanostructure of water and how it can contribute to achieve the goals set by UN for the theme of sustainability in the planet and keep life on the planet in the years to come. I am the moderator of this session, and I would like to highlight the importance of this event that is starting today here in New York. Some of the lecturers are here in New York in person, others are participating from their countries, but it's important to highlight that the last time UN system had an event focused on the theme of water was in 1977 in Mar del Plata in Argentina. So we have about 45 years without a specific event on the theme of water in the UN system. So it's really a historic moment, and a group of institutions came together to bring this message of the importance of looking water in this level of the nanostructure level and the molecular structure of water and the water system, how it works with this zoom in. Yeah. So I would like to thank the supporters of the event, the partners institutions. So I'll tell the name of the institutions that are making this side event, official side event of UN conference possible. So thank to CIRAT, that's the International Center on Water and Transdisciplinarity, the Public Ministry from Brazil, Project Conexão Água Project, the Buckminster Fuller Institute, the International Panel on Water Structure. I would like to thank University of Washington, World Water Community, Water Journal, Giri, Associação Alternativa Terra Azul, Aquamater, Technical University of Denmark, Edge Institute, UNIP, Bion Institute, Hydration Foundation, Aquaphotomics, Abrampa, Institute for Frontier Science, and Instituto Federal de Brasília. So we thank you so much, all the partners that are together to make this event possible. We started some years ago, this partnership between many institutions to make this approach for water more known. This is something that is much more on the radar of people from academia, from universities, but it's not on the radar of people from the water sector, from sanitations, from the engineers. And what we are trying to do today is try to create those bridges between those worlds that is very positive for the world, for life in planet, that we advance creating these bridges in order to achieve the sustainable development goals. So we have a keynote speaker this night. There is Professor Gerard Pollack from University of Washington. So Professor Pollack, I give you the floor. You have 20 minutes to make your presentation. Thank you so much. 20.
Okay. Thank you, Sergio. Let me just get this in the right view. let's see. I need presenter view. Let's see. Okay. Well, thank you for the invitation. I'm thrilled to be here, and I would like to talk about the fourth phase of water. We all know three, and I'm going to talk about the fourth phase. The first question is, do we really understand water? And, you know, typically people think, oh, well, sure, water has been studied for hundreds of years. It's such a simple molecule. Everything there is to know about water must already be known. And I would like to challenge that view in the next few slides. So here's something that you see all the time, a cloud sitting above water. First question is, you know, the water is evaporating from down here and forming a cloud up here, but the water is also evaporating from here. How come there's no cloud right here? Second question, what keeps the cloud up in the sky? It's made of water. And if we were to climb a ladder up to this height and take a pail of water and turn it over, it would come down like a waterfall. But the cloud stays up, typically. Why? And if you don't know the answer, then you don't know all there is to know about water. Here's another example. This is a lizard that's found in Central America. And it's seemingly quite content on the limb. And when it gets inspiration, we don't know what the inspiration is, it jumps off, and what it does is it walks on water. Now, because it walks on water, it's called the Jesus Christ lizard. How does it do that? And if you don't know the answer, you don't know all about water. Another one from Elmar Fuchs, two beakers sitting lip to lip, filled with water, put an electrode in this one, put an electrode in this one, impose a high voltage, and what happens is a bridge forms. And if you move one beaker with a mechanical stage away from the other beaker, the bridge persists, and it persists for up to 3 or 4 centimeters and essentially indefinitely. Now, most of you are not familiar with water doing something like this. How do you explain it? And if you can't explain it, then you don't know all there is to know about water. Well, for me, the inspiration came, I was in a different field. Inspiration came from this guy, Gilbert Ling, who came from China as a very promising scholar. And unfortunately, he passed at roughly age almost reaching 100. And he was talking about water in biology. And he had evidence and theory about water in biology being so-called structured or ordered. That is, the molecules were not bouncing around randomly and disordered as we think in liquid water, but they're actually ordered like soldiers at attention. Well, it got my attention. And we started the first thing to do after putting together a book on Gilbert Ling's ideas was to do experiments. And his central idea, we started from his central idea, which is shown here. So inside the cell, there are lots of solids. They're mostly proteins. And the proteins have typically hydrophilic or charged surfaces. And the water molecules, which are shown here as simple dipoles, they've got a plus here and a minus here. And you can imagine how the plus here sticks to the minus here and so on. And so there might be some order in the first and second and perhaps beyond layers. And conventional physical chemists admit, yes, there may be some kind of molecular order in the first couple of layers, but not more. The effects of thermal motion or Brownian motion are disruptive, and they created disorder. And Gilbert said, no, you guys are wrong. The ordering extends not 1 or 2 molecular layers, but well beyond. And he was talking about maybe even hundreds of layers. And I'm going to show you that although our experiments show that this particular model is not quite correct, and there's another model that fits the data better, but the ordering extends to hundreds of thousands in the right situations of layers. It's enormous amounts of order. So in thinking of Gilbert Ling's ideas, we thought of this as being a kind of crystal or liquid crystal. And we know that when crystals form, they push out all the impurities or solutes. And so we were looking for some kind of experimental preparation where we can see water that excludes particles or solutes. And we found it rather quickly. So here's an experimental chamber. And sitting in the chamber is a gel. This was a polyvinyl chloride gel to start with, but it's not important what the name is. Here's the boundary. And this is water. And into the water, we put particles, microspheres. This is one of the first videos that we actually took. So we looked in the microscope, and even before we turned on the video, we could see a region where these microspheres were excluded. And we thought, well, maybe, we had no evidence at the moment, maybe this is a region where the water molecules are ordered as Gilbert Ling had suggested. And if you look at the video, what it looks like is there's something that's growing here and pushing out these microspheres, and it's pretty sizable. 50 micrometers is approximately half of the thickness of one of my hairs, if I had any. So, you know, by molecular standards, that's pretty sizable. Someone suggested that instead of going through all of this discussion, that why don't you just give it a name? Because we kept seeing it with different materials here and such. And he suggested we call it exclusion zone, and because it's water that excludes, so it made sense. And exclusion zone, EZ. Now, in the US, EZ is easy to remember. In other countries, it's EZ, and so it doesn't quite work as well. But this is this water is we commonly refer to this as EZ water. And later, when we found that the properties of this water are so different from ordinary liquid water, we began calling it fourth phase water. So EZ, fourth phase, the two are roughly synonymous. Now we look for evidence, and some others as well, evidence that EZ water is physically different from bulk water. And this is a list. This is a list constructed in around a decade ago, and if we were to construct a list today, it would be a lot longer. But even by then, we had I think there are 8 here, and in black is the conclusion of the study that we found, essentially all published. And this is the technique that was used. And I don't want to go through in 20 minutes all of these, because it would take me 20 minutes to go through one of them. But I just, in fact, want to talk about this one because it's critically important. EZ has negative charge, typically. And these come from direct measurements of electrical potential using microelectrodes. So we found that the exclusion zone, growing next to these hydrophilic surfaces, the exclusion zone typically has negative charge. And because everything starts with a water molecule that's neutral, you can't just have negative charge. There has to be an equal number of positive charges somewhere else. And we found it, again, direct measurement here. So this is like a battery, a negative here and positive here, battery with potential energy. And the way it forms is what we found is that, you know, it begins with water molecules. All here, we started with water, simple water molecules. And I think many of you are familiar with the molecular structure of a water molecule. And we found that some energy comes and breaks the bond, either here or here. And when you break the bond, what you have is one part of the molecule, the oxygen 2 minus and 1 plus gives you a net of 1 minus. And on this side, you have 1 plus. And so we found it's actually this fraction here of these molecules that assemble to form this negatively charged zone. And here the protons are sitting here in the water. And indeed, we have a battery. All batteries need charging. And the question is, well, what charges the water battery? And we found, actually, it was a student who found, we didn't find anything. And we were just scratching our head to figure out, where does the energy come from? And he found that it was light. He was just sitting with his chamber, and he took a lamp, and the lamp was directed to the chamber. And so this is actually one of his experiments, his real experiment, and this is obviously artist drawing. And so it starts with some kind of material with a hydrophilic or water-loving surface. In this case, we use Naphion. We've used many different surfaces, but often Naphion is a polymer that's really convenient. So this is a polymer film. And the exclusion zone is shown here, and the microspheres are here. And the boundary between the exclusion zone and the microsphere containing zone is parallel to this. This is typically the case. But he noticed where he was shining the light that the exclusion zone grew, and it grew measurably. And he called me in to show me, and I was astounded because we had been thinking for a couple of years, where does the energy come from? And we couldn't figure it out, and he had it. And so we did real studies, and we found that the most effective wavelength is not visible light, it's not ultraviolet light, but it's infrared light, which is all around us, and everything is generating infrared light. You can pick up this light with an infrared camera. Even if it's completely dark, you get a wonderful image of everything out there, and that's why it's common for the military to use this to see in the dark, and you get a very nice image. Now, because infrared energy is abundant, it also comes, by the way, from inside us. Metabolism generates heat, and the heat is roughly equivalent to infrared energy. So it means that if the energy is there in the environment, it means that if you have the correct material, the hydrophilic, water-loving material next to water, you're always going to have some EZ water. This is ordinary water, and a fraction will be EZ. Now, if you increase the amount of infrared energy, then the EZ grows. And if you decrease it, it comes back to the default situation. So you've always got it. So energy for buildup of this is not complicated. It comes from photonic energy or light. Light is what builds it. And those of you who know about plants will understand that step one in photosynthesis is light breaking up the water molecules into plus and minus fractions. It's light that charges the water battery. So, you know, some of us will maybe enjoy going to Rio or to Hawaii and just lie in the sun and pick up all of that infrared energy to recharge us. So if we can get recharged by infrared energy, then the question arises, well, can we harvest this energy? Can we get it from somewhere? And I think that probably not one of you has noticed that you can take a glass of water and you can get work from a glass of water. But I'm going to demonstrate that, yes, indeed, you can. And it happened with another undergraduate student. See, all of our results come from undergraduate students. They're open-minded, they're bright. And in this case, we found out that Naphion, which I showed you previously, not only comes in sheets, but also comes in a cylindrical form, like a tube, like a straw. And he put it in water. I asked him, please, can you see if an exclusion zone forms on the outside and on the inside? We wondered, because this is not flat. This has a tubular shape. Would the tubular shape interfere with the idea of building exclusion zone? And he quickly found, yeah, we found an exclusion zone outside and also inside. Unfortunately, I was away on a trip. And this was a conscientious student who really wanted to do more. And I wasn't there to tell him or to misdirect him. So he did his own. his own stuff. So a couple of weeks later, I'm sitting in my office with a visitor. I think it was an important visitor, but it was a little bit boring, and the student came and stuck his head in, open door, slightly ajar, and he said he basically barged in. He was not as polite as some of the other students, and he interrupted, and I showed a bit of disdain and irritation by that interruption. He said, "I have something I saw. I wanted to tell you about this." And I pretended I was irritated. I really wasn't irritated because, I was happy to be interrupted because the conversation was not so interesting. And he said to me, well, I see water flowing through the tube and it keeps flowing. It won't stop. And I'm thinking, wait a second. How could this be? Usually, if you have a tube and water is flowing through it, you need some energy. You need like pressure. For example, in our heart, the ventricle builds pressure and it drives flow through the large arteries. And that wasn't there. So I'm thinking to myself, if he's right, and we quickly checked that he was right about this constant flow, this is really important because it means that, well, the energy, we know that infrared energy particularly is being absorbed, and apparently it's doing something. It's actually doing work. It's creating something. So I was excited about this. And the way it works is you just put some water inside the tube, make sure there are no air bubbles, and you immerse it in water plus microspheres. And then you take it to the microscope and you look in the microscope under low light. And here's what you see. So Nafion tube, exclusion zone building, all the microspheres in the water are here. And so the water is flowing, and you can tell because the microspheres are moving. And we could see this going for as much as a day and a half without stopping. So it really was true. It's essentially indefinite. Someone said, well, this may be a queer, oddball properties of Nafion tubes. Why don't you try something else? And so we did. And what we did is we used gels. We stuck a wire in just before the gel gelled. And then we removed the wire and we got a chunk of gel with a tunnel. And we immersed that in water and microspheres. So here's the gel, in this case, polyacrylic acid, gel. Here's the tunnel. And when you immerse it in the water plus microspheres, quickly the EZ builds and pushes the microspheres to the center. And the same thing happens here. And if you look at the video, you get the same result. Boring. We tried a half dozen different gels. We got the same result. And someone said, well, you think all of this easy stuff and is built by light. Why don't you just add more light and see if it goes faster? So we cranked up the microscope light, and we found that indeed we could achieve a 5 times speed increase just by adding more light. And so it's a generality. And the question then arises, if this is a generality, does this apply inside our body? Is it possible? Because we receive infrared energy all the time, and our cells have the proteins and such have hydrophilic surfaces. So our body is actually the cells are filled with easy water. And we're wondering whether infrared energy can actually do work inside our body. And the first thought was the cardiovascular system. Now, I first began thinking about this when I was invited to Russia to visit my friend and colleague Vladimir Vaikov in Moscow University. He quickly introduced me to his colleague. And the colleague said to me, oh, cardiovascular system is a big problem. And I'm thinking, with my nose up in the air, what kind of big problem? I actually studied pressures and flows in the cardiovascular system for my PhD. And I thought I knew the answers, but he's telling me there's a big problem. What's the big problem? Well, the big problem is that red blood cells are supposed to look like this. We've seen many pictures of them, but the red blood cells are in fact twice the diameter of the smallest capillaries. What does that mean? It means that in order to get through those small capillaries, these have to bend. And it takes a lot of energy to bend them. So here's an example. This is muscle tissue. You can see the striations. And these are capillaries. You can see various capillaries. And you can see the red blood cells, as they pass through, they have to bend. And this guy's having a really hard time. So they have to bend, and it requires energy. How much energy? Well, they did a calculation. And calculations are based on assumptions, so we can't be absolutely sure. But they calculated that if the ventricle is responsible for this, if the ventricle creates enough pressure to drive this through, it would have to generate a pressure that's something like 1 million times the pressure that's actually generated in the left ventricle. That's high blood pressure, if you will. So their conclusion was there has to be another source of energy beside the heart. A shocking assumption. Now, I was thinking, I began scratching my head, and that accounts for the loss of hair. I was thinking that, we had just found that in a hollow tube, just like capillaries in a sense, in water, we get flow. And it's built by radiant energy. And so might radiant energy help drive blood flow? This could be that source of energy that the Russian colleague was looking for. And so we decided to do some experiments, and we did it on an actual circulation, the chick embryo. And my student, Li Zhang, who did the experiment, he told me that when I suggested this experiment, he thought I was in some kind of drug. He said, weird to think that something beside the heart might be assisting the circulation. But when he got a positive result, he changed his mind. So here's a 3-day-old chick embryo. It's fairly pure. Regulatory systems are not in place yet, or not fully developed. And you can see the circulation of the heart at the center. He developed an optical system to look at these regions, and the first thing he did, this is his main result. So here's blood flow versus time. The first thing he did was he stopped the heart. He wanted to see whether when you stop the heart, does the circulation continue? Now, you'd think the answer is, of course, no, but he found the answer is yes, as other people had found in the past, in fact. So you stop the heart, and the flow goes down, and it goes down not to zero, but to a low level. And then what he did is to test the signature feature of the laboratory phenomenon, which is you add infrared and you should get an increase of flow. And this is exactly what he found. And you remove it, and it goes back to the baseline. So he confirmed that the expectation of this hypothesis is confirmed. It doesn't prove it, but it's certainly consistent with the idea that your heart and my heart is pumped not just by the ventricle, but the vessels themselves are driving the flow. It means, if we're correct, it means that there are 2 drivers in your circulatory system, not just the heart. So radiant energy does help drive blood flow, so that energy is helping to propel something in our body. And we found, don't have enough time to present it, but that in essentially all cells, that easy water is not only present, but is actually an energy supplier of what the cell needs to do for a living. I'm going to end with a couple of practical applications. Practical meaning beyond biology. Biology is pretty practical, but okay. So the first is getting energy from water and sunlight. So you've seen this before. You got negative region here, positive region here. It's like a battery, and if you put 2 electrodes in, you should be able to get energy to light a light bulb, at least symbolically. And here's an experiment that demonstrates exactly that. These are, I think, a dozen cells, each of which has water, naphthalene, and two electrodes, one in the negative, one in the positive, connected together either in series or in parallel, depending on what you want. Here's a switch, and this is a magnifier sitting over a light-emitting diode, LED. And so you turn the switch, and it lights. This is just from water and infrared energy. And so I think this has a huge promise for the future. It's just simply a laboratory demonstration of proof of principle. But imagine multiplying this by 1 million times, getting energy from water and sunlight, very simple way, renewable. Another one is getting drinking water from contaminated water. And we all know contaminated water is regrettably all around us. And this shows how we do it. So you have input flow, and the input flow consists of water and contaminants. And as representative contaminants, just to make life easy, we use microspheres, which are actually roughly similar in many ways to bacteria, even the same size, roughly. That's our contaminant. And if you put it inside a naphthalene tube, we've demonstrated that exclusion zone builds here, pushes the microspheres or contaminants to the center. So we built what we call a differential extractor that collects the junk here and dumps it. And then also we collect the exclusion zone water, which is basically excludes the contaminants. And we see it here. And we've been able in a single pass to get a 200-to-1 ratio. So it shows promise. And we spent some time improving the throughput from the simple laboratory proof of principle demonstration to one that's 2 or 3 orders of magnitude faster. So the real prize in this system comes in the separation of salt. Now, there's no external energy that's required. All the energy comes from the sun and from infrared energy that's around us. So if we can separate salt in this way, and we have some, again, proof of principle that we can separate salt this way, not many experiments, but a few, we have a method of achieving desalination with no external energy input. In other words, you can take ocean water and get drinking water out of this without any input of energy. So this is another promising outcome as well. So in conclusion, in 20 minutes, I've not been able to give you much evidence, but we have evidence for that water has a 4th phase, not just solid, liquid, and vapor, but an EZ phase that has properties completely different. Essentially, every property differs from property of liquid water. And it has broad implications. The central implication is that the water is always absorbing radiant energy and using that radiant energy, not just dumping it. I've given you an example of blood flow, where that energy, the absorbed infrared energy, gets used to propel blood. In aspects of chemistry, the textbooks that we read has nothing about charge separation, the effect of infrared energy and such. And so some of the interpretations of reactions that occur in aqueous solution will need to be revisited. Weather, we talk about temperature and pressure. Clouds are charged, not just thunderclouds, but all clouds. And I would venture to say, and it's coming in my next book, that the primary variable, because these contain easy water, they contain charge, primary variable is going to be charge, not temperature or pressure. In terms of health, well, your cells are filled with easy water. They need to be always filled with easy water. And if they're not, your cells are dysfunctional in some way. Food, if you want to freeze or evaporate, dehydrate, it's good to know something about those processes. And in terms of what we call practical, if these are not practical, one of them is filtration, to clean up all the dirty waters. And desalination, drinking waters are desperately needed, not only for drinking, but also for agriculture. And getting electricity from water. These are important attributes, and we're on to them. And many of this appears in the book that my last book that's published, and it's become very popular. So thank you very much. I will end here.
Thank you so much for this brilliant lecture, Professor Pollack. Really very interesting and showing very clearly the great potential in so many fields of life, yeah, that those researchers has, and the necessity of advancing on this field of research. Yeah, I'd like to inform for all the participants and everyone that is watching the side event that you can put in the chat from YouTube and also on Facebook questions that you have regarding the lectures that are being done here. So you're invited to write down, and then we'll select. We'll see if we will be able to read all of them. But the idea is that in the final part we have some interaction with the public. Okay, so let's advance. Now we start the other lectures. The lectures from now on has 7 minutes each to make their presentations. And so it's an honor for me to introduce Everine van der Kratz from World Water Community that is going to talk with us, and you have the floor. Everine, please go ahead.
Thank you, Sergio. Also, very many thanks for starting this initiative with all the partners together with the New York Statement, because I think it's a great step to bring our message further out into the world. And hello to everyone. Solving water challenges requires global collaboration amongst all people and organizations. Therefore, I'm very excited and delighted to invite you into the World Water Community, where you can make connections, collaborate on projects, and much more. Most of the speakers that you will hear today have already joined. So what is the World Water Community? Well, it is you, because you are water. If we truly understand that we are water, we have the power to transform the world. And the World Water Community is the global hub for water. It's a watering hole for you to quench your thirst. Here you can dive into an international network of individuals and organizations. All of them are water stewards with their unique experience, knowledge, and skills. It is for old and young, and for experts and novices. You are all welcome, as long as you have a love and passion for water and are contributing to solving water issues. So come drink with us. You will find inspiration, knowledge, in-depth conversations, solutions, projects, events, and opportunities for inner reflection and growth. It is not about who you are today, but about who you will become. Because the more we truly understand and live by the essence of water, the more we will be able to solve all issues in life. And the key to our success is learning to work together from our individual tunes and contributing our unique part to the whole. So why join the World Water Community? Well, to feel connected to the source of all life. And we are dedicated to the global to local healing and restoration of our planetary and internal waters. We offer a variety of tools and shared workspaces and services for us to bring our vision into reality. With these, you can increase your impact, efficiency, and effectiveness. So come and explore for yourself. And now related to the UN Social Development Goals. Our members are very aware that understanding water brings solutions for many of the world's problems today. You just heard. Cutting-edge solutions are already being implemented, and they are based on new insights and knowledge we have about water. I will mention a few here, such as purifying and optimizing water quality, bringing back rain even, reducing water use in agriculture, and this can be done through natural solutions such as living machines of John Todd, restoring the water cycle, or syntropic and regenerative agriculture, or by new water science-based technical solutions, such as new types of filtration, revitalizing and informous ecosystems via energetic, electromagnetic, or geometric or dynamic treatments, and so much more. Related to this emerging water science, the World Water Lab is an initiative to empower cutting-edge water science through collaboration. Our vision is to positively influence the future of water science, to bring forth solutions based on water science for current societal and planetary issues, and to accelerate a scientific revolution across all sciences. We are a community of individuals and organizations coming together to advance the as yet unconventional water science related to the hidden properties of water. We're scientists from different disciplines and backgrounds, and people from all walks of life, such as entrepreneurs, inventors, healthcare practitioners, indigenous, intuitives, artists, educators, and many more. Our common intent is to be a thriving, respected, and well-funded scientific field while bringing forth discoveries and solutions related to water as a result of deeply understanding and living by the essence of water. We thrive because emerging water science is indispensable. The sap in our tree flows as we bring solutions, expertise, and commitment into the world. And as a result, people, requests, and funds flow towards us. And in the soil, we do our work. We have three main routes: fundamental science, applied science, and product development. And together we meet, discuss, and interact. And we work on specific projects to deliver high quality water science. In the Crown, we spread our work, and we have four main branches: creating awareness, education, a knowledge hub, and implementing solutions. We are organizing webinars, media outreach, and awareness events, and developing courses, university and school curricula, building a World Water Library and sharing our publications, and implementing pilot projects and quality marking solutions. In short, we want to bring the huge potential of water science out into the world, expand our field, and become a strong voice together. So come drink with us. And I look forward to seeing you inside the World Water community. That was it. Back to you, Sergio.
Okay, thank you so much, Eveline, and thank you also for the great work you're doing those years with World Water community and the great contribution on putting all the researchers together. So now, advancing here on our event, I would like to invite Romiana Senkova from Aquaphotomics to make its lecture. So you have the floor, Romiana. Welcome.
Sérgio, acho que era eu.
Okay. Thank you very much, Sergio, for the introduction and for the really chance to be a member of this absolutely important initiative. It is right time, I think, to, even though in this big event of UN on water conference, just a small part about water science, but it will make a big change, I think. What I'm going to talk tonight is about our new platform for science, education, and technology. We call it Aquaphotomics. And it's all about water and light interaction. So we use light to read water and understand it, as well as the function of water for life. Aquaphotomics is all about water and light interaction. This is the spectrum of water over the whole electromagnetic range. And anytime I present something about aquaphotomics, I use this slide because it's every time amazing. This is the only system and I call it supercontinuum spectrum, borrowing the word from laser science, because it is absolutely fascinating that water is a system that can absorb any light, any energy from electromagnetic spectrum. I proposed aquaphotomics in 2005, and since 2021 we have aquaphotomics research field at Kobe University in Japan. We know that water is mirror, but it's mirror on macro and mirror and nano and micro level. So, but the point that I want to make with aquaphotomics concept is that the water is a matter and energy mirror. It's a collective mirror. Our science at the moment is mostly reductionist. We have so many omics disciplines that are very deep, looking at particular components, molecules, but we cannot understand the function of the system if we don't see the connections between the elements of the system. And the only connection, we could see all those elements through the water, because water is a mirror. Why? Water is a highly dynamic molecular system in a femtosecond range of time, and has a various structures of single molecules. So and I like this, what is this H2O, but it's not just H2O, it's a system of H2Os, and that make various different structures leading to different functions, because with the functionality and the possibility to adjust to the environment. It is a self-regulating system. And these are all different, of course, these are not all, but some examples of isomers of different water molecular structures. When we see different structure, then we know that it leads to different function of the water. And this is something new, that's something that we probably nobody imagined, that water has a specific, and not only one, but different functions in this world on different levels. So and why aquaphotomics, the point of aquaphotomics is to learn all these specific water frequencies, all the energies that water molecules, that those molecular structures are vibrating, and then we call them the letters. So, and we tried to discover them to make an aquaphoton, which is a database of those bands, and those are our water coordinates. So we will use the information at those bands, and then because in each system we have different structures, so which means we have a complex of these bands that they make the pattern, the spectral pattern, and a combination of those bands. And I call this the words. So these words are telling us about the functionality of this particular water molecular structure. So it is having a structure of water molecules already means functions. So, and this time I decided to use also the word ultimate system, because a water molecular system with all the molecules structured in different ways according to the environment and the function that they're supposed to do, and being a mirror of the rest of the system, water could be a source, a light source. It is a light source simultaneously with a sensor, a light sensor, because water structures, as Giri just mentioned, those molecules need energy. They absorb energy and they're structured. And by getting structured in a different way, they do different work. And on the top of it, they can regulate themselves, self-regulate as a system, becoming a probe to the rest of the system. So they bring all the information for the system. And all these conclusions we made by analyzing those systems. We started with milk, for example, and the spectrum of milk, of the water in milk, told us that it's possible to diagnose inflammation. And next step was bacteria, water and food, and different biosystems. At different levels, so looking at many systems, we got these conclusions. And the idea of having aquaphotomics as multidisciplinary science and technology. Most of our experiments are based on infrared spectroscopy, and these are the instruments that we use. Of course, other groups use terahertz and infrared and Raman, etc. Light, because the light has different energy. Well, this is how we do experiments. We are portable devices, and of course, here we analyze, for example, deep ocean water. Why? Because we can design water with required functionality. For example, this is, we call this aquagram, which is based on the letters, on the main water absorbent bonds that we already have discovered. And this is the pattern, this is the word. So we see this pattern. For example, when I saw for the first time, this is the aquagram of the deep sea water. It looks like mother's milk, like the water in mother's milk. The rest of the aquagrams are the mineral, for example, mineral waters. And if you combine mineral water with deep sea water, we can design a new water with new structure, means new functionalities. So we did lots of experiments and lots of application using spectral pattern as a biomarker for diagnose, for measurement of different components, but mainly what is good for non-invasive spectroscopy, what is infrared, is that we could do dynamic spectroscopy. We can do real monitoring, and based on that, we could see how the system is changing under certain perturbation and how the water is changing under certain perturbation. So that's why we could discover and understand a lot of phenomena in biological and life systems. So we understood oxidative stress, we understood diseases, and so what I would say, all this experience with so many systems and so many different applications brought us to the future ideas. We have already many papers out there, and we also have work also in our lab about showing that water has a coherent and non-coherent phase. And it's non-stop in phase transition between those two. Again, in the femtosecond time region. And quite a new, it's very now with quantum computers and using even photons, what water actually is a quantum computer, and it is a laser, and this laser, because when we have these coherent water molecules, most of them are coherent, when they restructure, they emit light, coherent light. They are lasers. And because water, molecular structure, there's plenty of water structures with different optical properties. This is the reason that water can produce this super continuum spectrum, which means what Giri noticed also, that water can produce light. And also, light does work into the water. Light restructures the water. It is a feedback of a system. So that's why this is the water is the ultimate system. This is the perfect system. So our recent experiment showed the coherence between sound and proton. So what we did, it is interesting. So we introduced different frequency of light in our paper at two different waters. Aquagram, this is the figure that shows the spectral pattern of each water. And you could see the differences between how different waters react to different frequencies. We have different reaction to different frequencies, which is directly related to the coherence in water and coherence of the sound. And this idea we implemented for people. We had nearly 40 people with under the sound treatment. And these are the aquagrams, the average aquagrams for different spectral region, means different spectral regions show different water structures. So we could see a very systematic change of the spectral pattern following. So we have a silence and then music mode and then silence again. And we could see a different behavior of the spectral pattern following the sound. So it's not, a sound is always combined with infrared light. And what Giri mentioned is the infrared light is structuring water. Yes, sound also. Sound brings coherence. So these are so many different areas that we have applied and still to be applied, because we can use, for example, terahertz as well. In our experiments, mostly in infrared visible light to probe the system through the water. By knowing the water structure, the water is reaction to the perturbation, like temperature, wind, whatever. So we could see what is inside the water, and we can measure it, even though we could have a single molecule, small, very small concentrations. Through the changes of the water molecular structure, we could measure those small concentrations of different components. I think that from now on, and this conference is a very good illustration of this, it is very important to emphasize on education. Every person has the right, I think, to learn more about water and to know about 70% of our Earth and our bodies and maybe the cosmos. So we have to be more educated, and we have to learn more. So that's why we have our website of Aquaphotomics International Society. We have webinars nearly once or twice per month. We publish our first book on Aquaphotomics. Our citations are increasing in the papers also, unexpectedly, and this is the future. So we need a huge database of all the water spectral bands, absorbent bands, the frequency, the specific frequency of what's related to specific structures, and then the combination of those bands making spectral patterns that are biomarkers. And then immense applications in different areas. Thank you very much for your attention.
Thank you so much, Romiana, for this so interesting presentation showing so many other possibilities that those researchers can bring. So thank you once again, Professor Romiana from Kobe University and from Aquaphotomics. I would like to inform to the audience that we are going to have, we are having this virtual event today to make it more accessible for people that are not in New York City. But tomorrow, March the 23rd, by 2 p.m., 2 in the afternoon, we're going to have a presential event in the Blue Gallery, also as a side event of the UN Water Conference, where we are going, many of the lecturers here are going to be there to talk a little bit more on those themes, but also to sign a cooperation agreement for the years to come, and also launch a statement showing the relevance of this field of research in order to achieve the UN Sustainable Development Goals. And one of the main proposals or goals of this group is to create an intergovernmental panel on water structure inside the International Hydrological Program of UNESCO. In other words, to have the attention of the UN system to this field that, as all of you can see, has a great potential to deliver a positive change for climate adaptation and industry and health and so many areas of our day-by-day life. So let's follow and just on the event of tomorrow, the 23rd of March. It's going to happen on the Blue Gallery. You can Google it and you'll find the place. It's going to be at 2 p.m. and everybody is welcome to be there. So advancing here with our event, I'd like to introduce Professor Michael Basch from the Technical University of Denmark. So Michael, you have the floor and 7 minutes for your lecture.
Thank you, Sergio. I'm not a professor, I'm just a senior scientist. Let's see if we manage professorship. Can you see my screen? Good. Yeah, so water, as Rumiana mentioned, is actually a water network, and industry, at least my impression is the industry is not really interested in the fundamentals of water. They just want to make money without looking further than the equipment. But water actually should have been boiling at -60. It doesn't, and that's because of the hydrogen bond, because of the network. This network changes extremely fast. It lasts only 10 picoseconds. It changes 100 billion times per second, which means it's really hard to see what's actually going on a molecular level. On this picture, this is a picture from Paris of the first person ever taken. There are hundreds of people on the picture, but the exposure time is 7 minutes, so we don't see them. But today, thanks to these incredible particle accelerators, we're actually able to go below the speed of water. We are now able to get roughly around 1,000 times faster than the water moves, and the bond moves. So it's a fairly recent advance. It also kind of explains why this field it's not an easy field to approach. Anders Nielsen managed to show that there are, in this case, 2 phases of liquid water. I mean, we talk a lot about different phases, and it seems to be at least 2 phases. And this is concluded from the different bond length in liquid water. So the question is, if we have this also at room temperature, this is subcooled water. There's strong indications that this is actually the case. Biology, as Gerald mentioned, is packed with water, but there's no such thing as free water in biology. Everything is near a protein or surface, and the water is very anomalous. It's not behaving like the bulk water at all. Recent advances show that we actually get strange behavior of water up to 3 to 2 nanometers away. So we have at least 30 to 40 molecules of water, which is really new words from an otherwise very conservative field. We have shown ourselves that we'll be looking at some morphine analogs from a block from South America, and this morphine is very strong. We don't know why it's so strong, but we can see when we investigate the chiral, there's a chiral group of this very short peptide, that the one that is active has a totally different behavior than the one that is not active. There's two versions of this one. And so only when it's in water, it's behaving differently. When you use all the solvents, it doesn't do it. So clearly the water is presenting the molecules, in this case, the chiral properties of a morphine analog. So there's no doubt that the industry could benefit from this, because as it is now, there are so many electromagnetic effects, statics effects influencing the water and what's in the water. You will have sound, you will have surface effects, and it's very empirical now. So the industry uses machinery that just works, but there's no real fundamental understanding on what the influence is on a molecular level on yeast and bacteria that you use in fermenters, for example. And the recent advances in material science as Gerald has shown us, we have a lot of potential to really shape the water that we are using. We're now able to use graphene materials that changes the dielectric constant of the water, so the water is less polar. We can therefore split the water molecule easier. We can do desalination systems that are based on pure sunlight. We're also able to mimic the aquaphotomics, the transport channels that nature uses. So there's a lot of it's a very positive, and there's a lot of upside potential on this one. And lastly, most of that has been about electromagnetic fields around water, but there's also the nuclei. The proton is able to do tunneling effects. So that means that it's jumping energy states. And this cannot be modeled using the general quantum mechanical programs we have now. So that means that if you have a tunneling event that is essential for enzymatic reactions, which basically is most of enzymatic reactions is in nature. It even also could lead to a much lower expense of electrolysis. I mean, water splitting, which now is it's way above the theoretical limits of how much it actually should cost to split the water molecule. So that has a lot of implications for power to X, like conversion of energy where water is central. Yeah. And lastly, I think, apart from all the economical implications and how much we can, as a human species, can win towards this, I find that the search for life on other planets is strongly linked to spectroscopy and how ice is behaving when you're looking at it through a telescope. So all the search for life, especially in our solar system, but also in other solar systems, is very much focused on water in different, very different extreme cases. So something that I previously didn't really understand so much about, which I definitely see now is fundamental. So there's so far 20 different ice forms, and more are being found almost on a yearly basis. So yeah, so that's my 2 cents. Thank you for listening. We have some more publications if people are interested. Thank you.
Thank you, Michael, for your very interesting presentation. Yes, we have partners from US talking, from Japan, now from Denmark, and it's really a huge group of institutions and researchers that are coming together to make this those kind of research even stronger and more on the radar of the UN system. Yeah. So I would like to invite Professor Igor German from Bion Institute, that is also going to talk on behalf of Carlo Landino from Giri. So Professor Igor, you have the floor.
Okay. So now I will speak about the very interesting association that was founded by Professor Madeleine Bastit. Its acronym is Giri, and the name stems from the French named Groupe International de Recherche sur l'Infinitésimal. And it was founded in 1986 by the already named Madeleine Bastide, professor, and Dr. René Hahn. The original aim, which for the most part has now been achieved, was to create a working group of earnest researchers to exchange ideas and results concerning the effects of very low doses and high dilutions. It was a starting point for an international group of scientists devoted to seriously investigating the phenomena and mechanisms behind high dilutions and homeopathy. Madeleine started scientific meetings that are still alive and a collection of books that stems from them. They tackled ultra-low dose effects in vitro and in vivo experimental models. The effect could be interpreted as a piece of information, in other words, as a signal whose transmission and perception remain to be elucidated. Giri as an international association was therefore primarily devoted to scientific validation of effectiveness of homeopathy and the development of the related basic research. At present, Giri is an international and intercontinental professional society uniting biologists, pharmacologists, physicians, chemists, physicists from all over the world. It has a main board, as it is seen on the slide, and an executive committee. The distinctive feature of the group's research activities is the study of ultra-low dose signals as they work on biological, chemical, and even ecological systems. The study of the effects of this very high dilution also includes homeopathy. Although the mechanisms of actions of very dilute solutions on biological and chemical systems is an important concern of the Giri Association, the association's major interest is directed toward the possible medical and therapeutic relevance of very low doses and high dilutions. Approximately every 10 years, Giri's editors launch a book of the series Signal and Images, containing the most significant lectures presented at the Giri meetings. The books are still available online, as it can be seen. Since 2006, Giri has decided to be the scientific sponsor of the Open Access International Journal of High Dilution Research. The group comprises more than 100 researchers from previously mentioned different disciplines from 22 states all over the world. It is open to all sincere researchers of the effects and mechanisms of ultra-high diluted solutions or homeopathy who would like to share their research with other similar researchers. Organization organizes yearly workshops, meetings that provide the participant the possibility to present their studies in the field of basic ultra-high dilution research or clinical homeopathy. The next such meeting will take place in Farmington, Connecticut, USA in October 2023. And the association is still hosting the International Journal of High Dilution Research. It is publishing the Giri meeting proceedings releases regular newsletters, supporting and facilitating the establishment of national and international scientific collaboration projects in the field of basic and clinical research in ultra-high dilution and homeopathy. It promotes high-quality basic and clinical research in homeopathy and the science of ultra-high diluted solutions. And of course, it also promotes collaboration with other associations pursuing similar aims. Thank you for your attention.
Okay, Professor Igor, you can continue because now you are going to present the Bion Institute, isn't it? You can go in the flow.
Okay. Just see presentations. So my next presentation will tackle what new water research can teach us about life. I'll present a new supposed connection between water and life. And we know that the life is considered to have originated around 4 billion years ago on the Earth. However, the new water science raises the question of whether life is constantly being created, even right now. Life or organisms may have at least 3 distinct phases occurring in parallel, of which nowadays only one is considered to deserve this mark, and this is life as we know from textbooks and from our school. So let us first look at some quirky manifestations that at least mimic living beings, and later let us connect this to water. There is far too little time to seriously ponder the scientific nature of life. However, it stands that there is no generally scientific consensus of this issue. Namely, what about the following entities? Are they living beings? Perhaps you all heard about prions. They are highly infectious agents actually representing deformed proteins that cause mad cow disease. Are they living beings because they behave like parasites? Or what about very well-known viruses? Do they possess their own life, or do they simply share the life of their hosts? And what about even more exotic forms like nanobacteria, which perhaps nobody of you heard about, but we all know their products, namely kidney stones and dental plaques, for instance. Nanobacteria are mineral organic nanoparticles that form spontaneously in bodily fluids, and they can form cells and tissue-like morphologies, and may grow, proliferate, and propagate like living beings, and they are found all around us and even within us. Now, certain scientists connect nanobacteria to Wilhelm Reich's bions and even name them bions. So what about this, perhaps even more strange formations that mimic life? One of the scientists who researched them, James DeMeo, reported about moving creatures that are similar to amoebas and paramecia that were stemmed from bions, and they were acquired from totally sterilized organic and inorganic stuff. Therefore, there are few questions. Are there relatively simple units of life around us steadily emerging from water? Or even more provocative, is water in its highly ordered phase already alive in a way? Or can we resort to water for a new and more acceptable definition of life and organisms? It is generally accepted that life sprang in water, surface waters, ocean, as far back as about 4 billion years ago. Water is often thought of as simply a passive medium for the origin of life, and even in nowadays life, only as a passive medium. However, could it be that water played a more active role in the process? Perhaps it even carried its own invisible germs that contributed to the emergence of life. The key to addressing this challenge can be found in the emerging field of new water science. This field recognizes and studies not just the two conventional levels of water that we all know, namely bulk water, we swim in or drink it, and molecular water we heard about, but it recognizes also the third level, namely the mesoscopic one. So this mesoscopic water is formed from large ensembles of water molecules, and between this molecule there should be long-range and lasting dynamically ordered structures. This phase is largely overlooked by traditional physics and chemistry, which only acknowledges the existence of short-term clusters and short-range structures. But is there any evidence for mesoscopic water? Well, there abounds scientific evidence for this dynamically ordered water stemming from widely different areas of unconventional water research. The mesoscopic phase of water is also encompassed within theoretical frameworks, so not only in empirical, but also theoretical frameworks. One stems from an extensive empirical evidence of the exclusion zone water discovered by Professor Pollack, and we heard about that a little more before. It refers to water that is bound to hydrophilic surfaces. Another such theoretical framework stems from quantum field theory and discovered by Preparata del Giudice theory of water coherent domains. And we also know that in Herbert Fröhlich's theory, coherent oscillations that were a coherent phase found within organisms plays a significant role in coordinating living processes in living beings. So we can envision three basic stages in emerging of life, namely, life can be found in dynamically ordered water stage, so in pure water but dynamically ordered mesoscopic water. Then it may develop further into cellular stage, like seen here. These are vesicular stages like bions, nanobacteria, coacervates, microspheres, and so on. And later in this development, it can pass to a biochemical stage leading to contemporary DNA-based life. So instead of conclusion, I pose a challenging research program based on the following hypothesis: that the most primitive life emerges in dynamically ordered water structures bordering hydrophilic surfaces, that the next step, these ordered water domains clothe themselves into vesicular structures, maybe called coacervation. Through time and a selective process, the later developed more sophisticated and determined biochemistry that may be called cellularization. And in contemporary life, there is a dynamic equilibrium between the water order and order inscribed in the DNA and proteome. These different levels of expressions of life are simultaneously present throughout 4 billion years of life's existence on the Earth. Thank you for your attention.
Thank you so much, Professor Igor, for your excellent explanation. I'd like to remember once more that YouTube and Facebook is there open for questions. So if you have questions on the lectures that are being done, please send there and we're going to try to answer. So our next lecturer is going to be Professor Leonie Bonamin from Paulista University. So Leonie, you have the floor.
Okay, thank you very much, Sergio, for this invitation. And I prepared a pre-recorded version of my PowerPoint. I'd like to ask for our technician, Victor, to run it, please.
Vitor, por favor, coloca o vídeo aí.
Good morning to everybody. My name is Leonie Bonamin from University Paulista, São Paulo, Brazil. And I'd like to talk some words about the physicochemical properties and the corresponding biological effects of potentized high dilutions. So what does it mean? Yeah. So potentization is the process. Is something wrong?
We had a problem, Victor. Vitor, se você puder dar uma olhadinha, o que aconteceu no vídeo?
Is Leonie. So what does it mean? Yeah. So potentization is the process in which several high dilutions are followed by vigorous agitation. So this process is the main basis of homeopathic medicine's manufacture. And it has been the subject of basic research in the last 35 years. From this research, we can see that there are lots of different biological activities related to plants, microorganisms, animals, and even humans. And all these researchers, or most of them, can be reached by using the main database called PubMed, in which more than 6,400 results can be reached if you put homeopathy as a keyword in this database. So how to understand high dilutions and the biological effects of high dilutions? Because most of them are prepared above the Avogadro's number. So we cannot expect any molecule of the original solutes in these very high dilutions. So how to understand it? Then most researchers in the last years have been working in this subject. And one of them is Stephen John Cartwright. Some years ago, he had a very brilliant, very interesting idea. That is to use subatomic dyes as probes to identify changes in the solvent polarity. And it happens when in contact with these potencies. So it was a very interesting discovery because it's possible to find a physicochemical marker of these potencies. And it's possible because subatomic dyes are dipole molecules that can interact easily with water molecules because they are dipole too. And we could see that this possibility to interact with subatomic dyes has a high correspondence with the biological effects of these potencies. And it's also possible to track the high dilutions activity in water. And it can be done in laboratory conditions using cell cultures, for example, but it can also be seen in field conditions in very, very huge water volumes, like lakes, for example. So what is the practical importance of this finding? Here you can see in this diagram that water research is in the center of our interest. But if we study homeopathy in high dilutions, it's possible to link from one side all the other subjects involving basic research on water, mainly on water structure, for example, nanostructures or easy water or coherent domains or water dynamics, etc. And these subjects can be linked to the more applied ones, for example, technology, sanitation, society, environment, health, etc. And now these subjects are linked to one another in an integrated approach. So if we practice this approach, it's possible to reach faster the ideal condition that we are focused on, that is the concept of One Health, in which a safer environment, the animal health and the human health are closely linked one another. It's not possible to promote human health, for example, without animal health, without take care of animal health and environment health, and vice versa. So maybe this approach can be a very useful tool for the future and the next generations. And if you want to go deeper in this subject, here in the bottom we can see the title of some publications done by Dr. Cartwright and by our group in partnership with him. So have a good reading, and thank you very much for your attention.
Thank you so much, Professor Leonie, for your interesting presentation, giving some new concepts like this one of One Health and the potential of high dilutions for health, not only for humans, but for animals, and this concept of health on the planet. Thank you so much. And now advancing on our event, we are going to the final lectures. So I'd like to introduce Professor Nicolaj Blum, that is a senior scientist from Denmark. So Nicolaj, you have the floor.
Thank you very much, Sergio. Just a remark that I don't think I'm the last one, but I know we are nearing the end, but let's see. Okay. So it's a great pleasure to speak to you today. And since we are celebrating, or we are having the UN Water Conference this week, I think it's very pertinent that we also not only look at water as the problem, but also think about the possibility that water may provide some of the solutions to some of the United Nations Sustainable Development Goals. I would like to start my presentation with showing you a short video presenting some of the amazing properties of water. So here we go. Without water, no life. Biological life has emerged in water. Our lives depend on it. We are even mostly water ourselves. But there's a lot we still don't know about water. Based on my research in water, I think we are on the brink of discovering water as a new source of energy or medical treatment. I just need to find the key to unlock water and its hidden potential.
According to traditional science, water is a simple molecule with a simple behavior. But in my laboratory, I observed how water molecules can be forced to act in a way that actually changes the physical properties of water itself. Take, for example, the experiment, the floating water bridge. When I expose 2 glasses of absolutely pure water to a high electrical field, the water molecules are forced to connect and form a rope-like structure that is able to hold its own weight in free air. This opens up for a whole new understanding of the potential of water. But so far, science cannot explain. I cannot explain why water acts like this. That's why I, together with some of my colleagues here at D2U, are searching for the proper measuring tool. Maybe even to be found in our own backyard or used in previous science projects. A tool that can unlock the mystery, decipher and measure what I now can only observe. It's like trying to find the thermometer, enabling us to tell the temperature of a substance. I'm sure my quest will be met with a lot more obstacles along the way. But I will keep on going, because my work will maybe lead to a new scientific paradigm that will shift the future of planet Earth and its inhabitants, simply by exploring the most basic molecules of water.
Yeah, so now I'm happy that also Professor Pollack introduced the concept of the floating water bridge. So now you have it in more detail. So I'd like to ask you to imagine what if water had a superpower that we didn't really know about yet, or that we didn't really understand. And that might sound very like Marvel adventure, like animation games. But actually, we do have an example of that, not with water, as we all used to, but with light. In the 1960s, we discovered that light has a phase or state that is qualitative, very different from what we normally experience as light, which we call the laser. So what, just as a thought experiment, we said, okay, there's a laser. Could we also think of a waser, a water laser that Rumiana, Professor Chenkovic, introduced just a few minutes ago? And that points to also an issue in this field that we don't have a common terminology yet. So this waser that I call it here could also be known as the fourth phase of water. It could be known as the low density liquid, and or the coherent domain of water. So this is, I think, the hallmark of a new and very exciting scientific field, but also a technological field. Because I meet a lot of inventors and entrepreneurs who are developing technologies that already exist. They are not really sure how they exist or how they function, how they work, but they do something to water. And the effects that they see fit exactly into, for example, one of the UN SDGs, number 6, clean water and sanity for everyone. These technologies reduce limescale, biofilm, fouling, and grease buildup, for example, or they increase efficiency in desalination. We already heard about that, combustion, cooling, compression, pumping, and so forth. Some of them influence water in a way that increase and improve plant and crop yields. And now we are even seeing examples of some of these technologies being useful in the big issue that we are dealing with now with the PFAS compounds and pesticides in our drinking water. So I think this field of the new science of water is not just an academic exercise, it's also a technological field that has a lot of promise, and that should be it's important that people from both sides of that field are talking together and meeting. So let's listen more deeply into water. It still has a lot of secrets to tell us. And I leave you with words from the late John F. Kennedy. Anyone who can solve the problems of water will be worthy of 2 Nobel Prizes, one for peace and one for science. Thank you for your attention.
Thank you so much, Nicolás, for your excellent explanation and show in practical terms the potential of this new water science has to change so many fields of life in the planet, and how things works in our society. So we are going to the 2 final lectures this morning. So the next one is Tania Brito from the International Panel on Water Structure, IPWS. Please, Tania, you have the floor.
Good morning, everybody. My name is Tania Brito. I'm the Director of Knowledge Production and Innovation of CIRAT, the International Center for Water and Transdisciplinarity. And I'm here to talk about the International Panel on Water Structure. Like was shown before, like World Water Community and Giri, well, this is another network of researchers that brings together researchers from different knowledge areas and countries conducting studies on water structure. So to give visibility, raise public awareness, synthesize and disseminate the most advanced knowledge on water structure and its practical applications, the International Panel on Water Structure was launched during the 8th World Water Forum, which happened in Brasília, Brazil in 2018. The mission of the panel is to connect leading researchers and institutions that have produced knowledge on such emerging new science of water and from an interdisciplinary perspective. For the constitution of the panel, several institutions and researchers signed a technical cooperation agreement: the International Center for Water and Transdisciplinarity, the Institute for Frontier Science, the Forest Medicine Center, the Federal Institute of Brasília, and several researchers from Brazil, United States, Russia. And in the renewal of the agreement, what happened last year, other institutions joined, such as the Federal Prosecution Office and the University of Brasília, and also several other researchers joined this initiative. At the moment, CIRAT runs the executive secretariat of the panel. And the panel is organized into 2 working groups. Working Group 1, which has the role of gathering research and knowledge on water structure, and Working Group 2, that investigates ways of applying this knowledge on water structure in the most diverse branches of human knowledge. Among the activities carried out by the IPWS, we can highlight the conference entitled Nanostructure of Water and the Cutting Edge Discoveries of Science, within the framework of the 8th World Water Forum, with the participation of internationally renowned speakers. Also, within the scope of the panel, it was undertaken a diagnosis of the state of the art of knowledge on water nanostructure worldwide. It involved a mapping of competencies where information was gathered and organized on researchers and research groups that have developed research, technology, and innovation on water structure. And it was raised the scientific production on this issue. The main aim was to further the establishment of a network of researchers on the theme of the molecular structure of water. Another joint activity between partners happened during the 9th World Water Forum, held in Dakar, Senegal, 1 year ago. IPWS and 7 partner institutions, including Giri, Water Journal, UNIP, CIRAT, and others, organized a meeting of experts and launched a special edition of the Water Journal to advance knowledge about water at different levels and to find crossing over points between applied and basic research on water. Another meeting of the IPWS expert research team is to be held at the 10th World Water Forum in Bali, Indonesia, 1 year from now in March 2024. So we hope that these transdisciplinary networks of leading experts and researchers on the emerging science of water expand and strengthen, and that IPWS can carry on functioning as a convergence hub, a platform for the exchange of scientific knowledge among researchers from around the world on the top of molecular structure of water and its various developments. Thank you very much for your attention.
Thank you, Tanya, so much for giving this so clear perspective of the work of IPWS and what it have done in the past and the following steps in the next to come. So yes, we are getting to the final part of our event. We have our last lecture, that is Pierre Meadow from Edge Institute. So Pierre, please, you have the floor.
Thank you, Serge. So Sergio, can you hear me?
Yes, we are hearing you.
Okay, can you see the screen?
Perfect.
Perfect, good. Let's give it a go. With all of that has been said, I only can pick up a narrow section of selected issues, and I will do that in form of 4 different experiments that fit nicely in the context of this meeting today. And they all can be grouped under the quantum domain, so to speak, because they are regarding biophotonic emissions from water, from aqueous samples, the fourth state of water, or the fourth phase of water, EMF and water, which has effects on biology, and quantum electrodynamics, particularly in coherence effects that I'm going to talk about. So these 4 columns will be briefly highlighted in the next few minutes. So let's give it a start for the first one. Imagine, well, this is a study that has been done already 12 years ago. So take 10 milliliters of water, measure it with a photomultiplier tube, which is selective in this particular range, 300 to 700 nanometers, and do the background measurement. So that's what you get. Then at a certain stage, you introduce an infrared laser, 1264 nanometers, 5 milliwatts is enough, and you illuminate this sample for 5 minutes, not more. Turn it off, and to continue keeping monitoring the background emissions that you get from the photomultiplier tube. After about an hour, 2 hours or so, suddenly you see this. And if you look at these emissions, because what you have, the biophotonic emissions that you have on the ordinate the time, on the abscissa the time, on the ordinate you have the photon counts of the photomultiplier tube, that give you an emission in the blue range of the visible spectrum. Just use a filter, that's it. So we have here infrared light was pumping the water in such a way as to get an emission in the blue light range of the visible spectrum. This brings us to the second argument, the fourth phase of water. So this is the branching chain reactions of water as postulated by Voyekov already 23 years ago, which is a set of equations starting with water and ending with water, and radical oxygen species in between. So if we simplify this bulk of equations, then we come up with oxygen as a starter, and water, of course, and oxygen at the adduct side, at the product side, but also water. So what's the difference between the two? Where is there a chain reaction happening? Well, it lies in the state, in the triplet state at the very beginning, and in the singlet oxygen state at the very end. And if you calculate the triplet state, the energy yield, it's something like 100 and I'm not quite sure, 180 kilocalories per mole, which is equivalent to 7.8 electron volts, gives you a net energy supply. So this comes back as kind of a wrap up of that what Jerry Pollack said, as we have several aspects in this case that this energy can be used for. So we have first the chemical semiconducting properties. If we use to charge the water, the bulk water sample that we have, The charge stays in there. It's not just diffusing away once you switch it off. Yeah. And it comes with a pH gradient that you can actually monitor if you're using just dyes. Then you can actually use it to separate the microsphere solution by using light, as Giri Pollack showed us at the very beginning. Then you can use this as an electrical separation of the ZZ zone that you have already seen when using a membrane or naphtha membrane. And then, of course, you have the mass transport, as you have a classic example in the Californian redwoods that are 120 meters up or even higher, roughly 120 meters, that the water has to reach the canopy. And then, of course, blood capillary flow that Giri Pollack also mentioned in his introductory lecture. So this brings me to the third aspect, and this is electromagnetism, because somehow this is related with the field aspect that we haven't talked about a lot today. Given the fact that we are 60% or 70% water content by mass, but if you look at the molarity, so that the number of molecules involved in this particular organism, any organism, it amounts to 91.9% and over. Just take a jellyfish, it's even more dramatic than this. And if you look at that, what has been already published a couple of years ago, what does it has to do with the electromagnetic spectrum? So you have the geomagnetic field, which is the green line over here. Be aware that this is a log-log scale. So the geomagnetic field of Earth, then these are the laboratory experiments that we have, the circles. Then this is the magnetic navigation field strength that are used by many bird species, for example. And then you have the geomagnetic field effects and correlation effect that are associated to it. I'm talking here in terms of the Jardine-Libov effect, which is not really the topic of today, but it is relevant if you want to consider it. And then we have the thermal threshold up there. So we are far below the thermal threshold. So we're talking about very weak effects initiated by the branching chain reaction that give us a hormesis-like relationship. And we have done this in a setup, in various setups. So we have two of them that I'm going to introduce here. So the first one is fibroblasts exposed to an ultra-weak, a very weak electromagnetic field intensity. And as you can see, all the pro-inflammatory markers, IL-6 and TNF-alpha, so tumor necrosis factor alpha, go down. This is up here. Yeah. Then you have also the MMP1 complex, which is a collagen degrading substance. It's also going down after field exposure. And the field exposure is very, very low. We're talking about 13 nanotesla. So it couples to the water media and then directly has an effect on the biotic entities listed in there. And as a net result, it comes up that you end up with an increased collagen production. Somehow a rejuvenation effect with this very weak exposure. The second study that comes into this particular field of investigation is when you use keratinocytes, skin cells, that you infect intentionally with yeast cultures, in this case, Malassezia. So we have the same situation. When the infection takes off, the cells get under stress, and you have again a surge in infection. In all the markers, IL-6, interleukin-8, and IL-1A, 1 alpha. But as soon as the electromagnetic field, the weak electromagnetic field, is tapped on it just for a very short moment, and then incubated again, just as with the previous study, these inflammation markers go down. And human beta-defensine, which is an antimicrobial peptide, actually surges, given the cells more resilient, which means these Hackard cells can resist the infection much, much better. And actually, they survive. This brings me again, let's say, to the last topic, which is the quantum electrodynamic initiative that's grouped under this particular scheme. And I would like to put your attention to this particular graph. It looks a little bit messy, but it's quite interesting. We have the graph over here. We have the solid fraction up here till ice. Then it thaws. Then we have the liquid phase. And then it's the vapor phase. So we have the temperature on the abscissa. And we have the coherent fraction on the ordinate. But that's not at the moment not so relevant, because biota, living entities, under this Gaussian shape-like bell curve, drive in this tiny little window, so to speak. This is the ideal driving preconditions for living entities. And what Preparata and Garbelli in their theoretical work in quantum field theory came up with is the coherent fraction versus temperature. So the first calculation turned out not so nicely, but still you have a coherent fraction of up to 25%, let's say, at viable temperatures. Whereas Gabelli, when he did the recalculation, they could fine-tune the system and they came up with 40% coherent fraction at viable temperatures. That there's still coherent fraction available all the way up to almost 700 degrees C. So what is coherence in this case? So if we look at the classical quantum mechanical transition, then we have many players. Everyone is behaving individually, and there are infinite numbers of degrees of freedoms. So everyone is like a chaotic, messy situation, highly entropic. That's the case in this particular scheme. So if we envision a particle as one of these peaks that you can see in the sketch, then it's spread around all over the entire, let's say, area. If we induce a phase correlationship, which means there's coupling between these in single entities in such a way as they align to each other by merging their phase differences to become zero. So they all oscillate with the same clock, with the same phase. Then reduce this entire system to a single degree of freedom, and the system becomes negentropic. And this is obviously something very interesting, because look at the equation up here with the number of oscillators and the phase difference. Is this particular equation has no units. It's scale free. So it is valid for both the microscopic level as well as the macroscopic level. If you want, from biomolecules all the way up to macroscopic entities such as societies and maybe the entire planet. Again, let me put this 99% number parameter that we are consistent of. It's not mass that we're talking about, but number as molarity in this particular case that is relevant. If we put a little bit more details into the particular behavior, then it looks like this. So we take these water molecules and they oscillate coherently, so to speak. They form domains. And in quantum electrodynamics, we speak about coherence domains. So they oscillate as a single unity. There is no individuation possible between the single water molecules anymore. This doesn't mean they're static, they're highly dynamic. And we have heard already previously that but individual water molecules can flip back in, flip back out in femtoseconds. But important is that the coherence domains as such is there, even though the members jump in and jump out. And more coherence domains that join together form larger clusters. They're supercoherence domains, which again influence on the mesoscale and then eventually on the macro scale the properties of the water. And that's what we call them in the previous slide from Giuliana, Garbelli, and Preparata, the so-called coherence fraction FC, whether it's 40% or 30%. It's important to say that the coherent fraction is not 100%. Otherwise, life processes stop. They come to a sudden halt. There has to be a kind of a bias, 40% coherent, and the rest is incoherent in order that life processes can take place. So with that, I would like to conclude and put a question mark. So why have these particular properties not have been already addressed in the past, let's say 20, 30 years ago, or even 100 years ago? Because in our society, obviously, we put our focus on matter issues only, and we neglect the field aspects, even though quantum mechanics with Planck and Walter Nernst and all these pioneers, they have been already out there for 100 years. Okay, in their field, but we haven't taken this message beyond. So we need to include the energy concept and the informational concept. We have to look to at our tree of knowledge, as Jerry Pollack puts it, in such a way as to look at the very base of the tree. Maybe we have to prune it, to trim it in such a way as to look no longer at our specialized field of object, our specialization, but let's step a couple of steps back and look at it from a broader view and see, okay, maybe some preconditioning assumptions are not really valid anymore. They have been too simplified, but we take them for granted. And from that on, we build our scientific knowledge. However, if you look at these peculiar observations that we have already seen and presented here today, we know that this is not fitting, it's not merging. So we have to get it new in such a way as to squeeze in certain issues that we need to question mainstream views, look at them in a very critical way, and then become aware that these once called pseudoscientific results now become solid science. And we have to address the essence of the living states by considering the aqueous phase, because this is obviously a crucial player in life, and encompass in this particular approach the field aspects and the informational aspects. And with that, I'm already finished. I'm done. Thank you for your information, for your attention. Sorry. I'm
Thank
still
you
online.
so much.
Oh, yeah. Yeah.
Excellent, Pierre. Very nice. We
I hope
finished.
in time.
Yeah, perfect.
Okay,
So
good.
we finish our lectures with you with a very interesting approach in simulating so many interesting correlations between everything that was presented before. So thank you so much. We have already 2 hours our event. We need to go for a closing, but we said in the beginning that we would interact with the public, and we have some questions that were answered in the chat, but there are some that were not. So I would just put a block of 2 questions here. And then the first one is for Professor Pollack, and a question is: grounding and earthing, I assume, influences the easy water in the cells and assists in better circulation, affecting the blood's viscosity. It's a question, Professor. Did you got the point? You are muted. We cannot hear you.
Thank you for the question. Yeah, earthing or grounding is extremely important. And the reason it's important, I think, is that the Earth is not neutral. The Earth has a net negative charge. It came as a shock, if you'll pardon the expression, to me, because my original training was in electrical engineering, and I never heard from any professor of electrical engineering that the Earth was anything but neutral. And then a Russian colleague came to me and talked about the electric field of the Earth. I said, Andre, you must be talking about the magnetic field, not the electric field. He said, no, don't you know about the electric field? I had never heard of it. So he said, don't you know that the ionosphere is positive and the Earth is negative, and there's an electric field between them? And, I thought he was on some kind of drug until one of my students came to me the next day and brought to me Feynman's lectures, the famed Nobel laureate Richard Feynman. And then at volume 2, chapter 3, volume 2, chapter 9, a whole chapter full of evidence that the Earth was negatively charged. So I think the negative charge of the Earth is directly related to your question. So we found if we take water and we put negative charge in water, just by sticking an electrode and passing electrons, that the ordinary water gets converted to easy or fourth phase water, just by passing negative charge, we found, and we published this. So now if you think about your body, and if you connect yourself electrically to the Earth, and we don't ordinarily do that because we have leather soles on our shoes, thick leather soles which insulate us, don't connect us. So we're not connected to the negative charge of the Earth. On the other hand, we take off our shoes and walk on wet grass, or walk on the beach right near the ocean where the beach is damp. We're connecting ourselves to the Earth. So if we behave the same way as the water behaves in the laboratory, then by connecting ourselves to the Earth, we're actually building easy water in our body. And as I mentioned to you, I didn't have time to present evidence. Every cell in your body is filled with easy water. Easy water is essential to the well-being of every one of our cells. Well, maybe not everyone, because we never tested everyone, but we tested many of them. And the evidence is pretty clear. So if you're deficient in EZ for some reason, and your cells are, somewhat dysfunctional, connecting yourself to the earth may reverse that and make them functional again. So I hope that answers your question. Connecting us to the earth is important, and that's why people feel good when they walk barefoot or bathe themselves in mud baths or what have you, because they're allowing electrons basically to enter your body and build easy water. Thank you.
Thank you for answering the question, Professor Pollack. And then we are getting to our close. I would like to inform that we had about 200 people participating in the webinar here during the 2 hour of the event. I'd like to invite once more people that are in New York to tomorrow, 23rd of March by 2 p.m. to get there to the Blue Gallery. We are going to have a presential event on the same theme of the molecular structure of water. We are going to sign a cooperation agreement between many of the institutions that are here represented by their researchers and professors to advance with this agenda in the years to come, and also in this connection between applied and basic research, but also in the connection with the UN system. So everybody is welcome. We wait for you tomorrow, and I thank once more for all the lecturers. It was really a remarkable event. So thank you so much. And here we close our event. Thank you so much.